Hi everyone. DeepSeek R1 gained a lot of press attention earlier this year, functionally similar to reasoning models like OpenAI's O series, while being fully open sourced under a permissive license with relatively low energy requirements. In the time since, we've seen a slew of powerful reasoning models, both as closed services and as open source. Chinese reasoning models, including R1 and Qwen 3, seem to be leading in the open source space. There are notable exceptions, including Magistral from Mistral and NVIDIA's Nematron series. The talk will start with a quick overview of how generative LLMs are trained and fine-tuned, along with safety training, chain of thought, and how different models respond to reasoning problems. We'll then look at the different DeepSeek R1 versions, why we might want to change the alignment of them, and the process we use to align with Llama and the cost of doing so. For those of you who aren't familiar with how generative large language models are trained, on a high level, it involves training with the objective of filling in missing words in samples of text. To start with, these would be regular text snippets from things like books, Wikipedia, or articles. The result is a model that's good at completing text in a believable way by finishing sentences or appending new ones, such as the classic demonstration text from OpenAI back when they released GPT-2. The part in bold is what GPT-2 added to continue the text that came before. Nowadays, this looks just like regular autocomplete, but back then, it was quite a revelation. The base versions of models, as in the first sort of working versions, are still usually trained in this way, before moving on to training on more specific samples to give us the chat and code completion variants that we're all now familiar with using. As we'll be talking about a lot, let's take a moment to define what fine-tuning is. When we say fine-tuning, we're talking about training an already working model further on specific data, using far less data and computing power than training from scratch. The results of the original training are still there, but the model has now been trained with more specific data, taking it in a new direction. Stepping away from language models for a moment, in the center is a fairly realistic-looking image generated by the original version of Stable Diffusion Extra Large. It obviously has the information about what Barack Obama and Donald Trump look like from its training. To the left and right of it are pictures generated by fine-tuned versions of the same model, using exactly the same input text. These fine-tuned versions of the model have been deliberately moved away from realistic-looking outputs in the direction of the particular visual styles depicted in those images. It's very unlikely that the fine-tuning data included anything about what either of those look like. The information on how Obama and Trump look is still there from the original training of the base model. The fine-tuning process doesn't always work well. When fine-tuning, using a relatively small set of data compared to the original huge training set, there is a risk of training for too long or with too high a learning rate. Rather than nudging the model in a particular direction, you can end up overfitting to this small data set, losing the ability to generalize and suffering from what's called catastrophic forgetting of the original capabilities that the model had. The resulting model will be excellent at recreating the exact samples from your training data, but absolutely terrible, or much worse than the original model at everything else. To create the chat and instruction following models we're all familiar with now, these base models are post-trained, that's extensively fine-tuned, on samples formatted in a different way. The samples contain questions and responses or a more general two-way conversation, marked with tags to indicate, for instance, where the question ends and where the answer starts. When you chat with a service such as ChatGPT, the service wraps your input in the same tags that were used in the training data. The model is then tasked with generating text that completes the rest of the string, which would be the answer. For example, here's a question and answer formatted in the original Llama format. You can see the question part is wrapped in the tags marked in red. When the model completes the text, a chat service would return the part after the last tag to be presented to the user as the bot answering the question. Another thing we need to mention is safety training. As part of their training and post-training processes, large language models, particularly chat and instruct models, are trained on samples where harmful requests, such as requests to generate misinformation or instructions for illegal activities and inappropriate topics, are refused, and the conversation is steered back towards appropriate boundaries. Safety researchers are continually developing new challenges to test models' robustness, which feeds into future training, although there's a balancing act between the need for safety and the model's capabilities. Of course, what constitutes an inappropriate topic is somewhat subjective. There's far from universal opinion on that. The boundary between safety and censorship is an ongoing debate. Another term you'll likely encounter when it comes to safety is guardrails. Rather than being trained into the model itself, that's a piece of software that sits between the model and the end user, either filtering the user's input or filtering the model's output. In addition to what we're covering today, there are many popular types of fine-tuned variants of LLMs for things such as customer service, role play, code completion and infilling, instruction following when it comes to coding problems, story writing, legal knowledge, and many, many more. Something which is key to reasoning models like R1 is chain of thought, which is a method to encourage a large language model to answer in a step-by-step manner, which is beneficial to answering certain types of questions, as in those that can be broken down into steps. One way to do this is by simply instructing the model to break down the problem into steps. This can improve an LLM's ability to produce coherent and accurate responses. It was first proposed by a paper from Google Brain in 2022. In this example, taken from the Google Brain paper, you can see on the left a large language model simply answering two questions immediately and answering the second question incorrectly. On the right, the same model and the same questions, but now prompted to work through it in steps, and you'll see it's a bit longer. The second question is now correct, or the second answer is now correct, sorry. Most large language models are now trained to do this by default when encountering these kind of questions. Looking now at an example of a question that benefits from chain of thought. We have a simple maths problem that you might find in a primary school textbook or early high school textbook. Determine the greatest common divisor of 48 and 180. When asked this question, the 2-year-old Llama 2 model generates 141 tokens worth of output. It does document a thought process, but in a way that superficially resembles a child's textbook, or just a person providing a quick answer on the internet. Critically, the answer is wrong. Many question and answer data sets would have answers with this kind of short explanation. So Llama 2 would probably have encountered them in its training and thus generated just simply some similar text that looks superficially similar. The newer Llama 3.1 model outputs much more decisive steps, more resembling the step-by-step approach from the Google paper, outputting almost 40% more tokens, 195 in total, as a result. It's reasonable to assume this model was trained deliberately to answer this kind of question in this manner. This time the answer is correct. That said, the model does start to give incorrect answers when it comes to more complex problems than this example. Reasoning models like OpenAI's O series and DeepSeek R1 take this to another level. R1 outputs such a comprehensive chain of thought before answering the same question that it takes the token usage up by more than an order of magnitude compared to the original Llama example on the last slide, outputting 3,618 tokens in total, along with the corresponding increased time and energy usage that entails. This output includes working out for multiple methods of tackling the problem, also stating that the answers match and an additional sanity check at the end. This should mean we have a far lower probability of a wrong answer. Indeed, the answer is correct, and R1 has proven capable of consistently giving correct answers to far more complex problems than this one. R1 and other models of this type mark their chain of thought within tags, and then provide an answer to the user after this. You can see the answer in green there in the foreground, and everything behind it, all that tiny text in the background, is all the chain of thought it output before the answer. As part of the training process, a form of reinforcement learning is used where the models are tuned towards outputs where that result in correct answers to more complex problems and away from ones that result in incorrect answers. DeepSeek didn't come out of nowhere with R1. They've been one of the top publishers of open source large language models since 2023. Their first model, simply called DeepSeek Large Language Model, was released back then and soon followed by a version that specialized in coding. Since then, they've gone through multiple iterations of both, also introducing multimodal and math-specific models. The V3 version of their main language model has the same architecture as R1 and was released just a few weeks earlier. Of course, R1 created a huge stir with its reasoning abilities and the launch of DeepSeek's consumer app at the same time, gaining considerable mainstream press coverage. R1 was released as a set of models. These include the largest model that used an architecture called Mixture of Experts, or MOE, that was pre-trained on a non-reasoning data set as a starting point. People speculate this was actually DeepSeek V3. That's not known for sure. That architecture means that not the entire model's active at the same time and reduces the energy requirements somewhat compared to the whole thing being active. There's a version with the same architecture called R10, where they tried training it from nothing, but the paper that they released at the time says that this didn't match the capabilities of the one that had been pre-trained, and therefore that's not the main version. There are further models, all with names including R1 Distill, which with sizes from just 1.5 billion parameters all the way up to 70 billion. A technique called knowledge distillation is used to further train target models to match the outputs of the model being distilled, in this case the big Mixture of Experts R1. These targets are existing open source large language models from the Llama 3 and Quen families. The 70 billion parameter distill version, which is based on Llama 3.3, comes very close to matching the big Mixture of Experts model in capabilities and answers. It actually uses more energy to produce outputs due to the whole 70 billion being active at once. The advantage being that it will fit within less memory, and you can run it on some consumer GPU setups as a result. Now, to explain why we might want to tune R1 to be aligned with Llama. I don't want to get into some of the more controversial things that have been posted about this. However, what isn't controversial is that as a Chinese company, DeepSeek are very careful that their models adhere to the rules about content in China, to such an extent that the outputs can look quite jarring to those of us in the rest of the world. We had clients express reluctance to deploy DeepSeek's models in production as a result of this, and that was our motivation, really. If you look at the output from R1 about China's ambitious Belt and Road Initiative, notice that there's no chain of thought output that implies that it's a result of safety training. Many around the world will have good things to say about the Belt and Road Initiative, but there are clearly positives and negatives, and something like Llama or ChatGPT will explain those to you. DeepSeek's output, however, reads like a sales pitch if you look at the highlighted bits there. When it comes to changing the large language model's alignment using fine-tuning, a moderate amount of compute and samples that have a particular political bias can quickly take the model in a new direction. For instance, David Rosado, an academic from Otago Polytechnic in New Zealand, created a progressive left-wing GPT and a conservative right-wing GPT for a paper he was writing. While it doesn't require a lot of resources to change the bias of a model like this, it's also sometimes necessary to introduce knowledge that was missing from the original model, such as details of historical events that may have been censored from the original training data. There's also a risk of unintended consequences. A paper from OpenAI details how they, as an experiment, they deliberately fine-tuned a large language model to output flawed code when a user asked the model to generate code. The model started outputting undesirable answers to questions that are completely unrelated to code generation, including hate speech. Two of the distilled variants of R1 are an interesting case when it comes to what's needed to change their alignment. While many things may have been censored in the training data used for R1 itself, in these cases, models from Meta's Llama 3 family served as the starting point before the R1 mixture of experts model was distilled into them. While without doubt the distillation process to match R1 will have come at the expense of some degradation of the original Llama knowledge, and the chat prompt format has changed from Llama 3's, much of that knowledge does remain to some extent, including any details that may have been censored in DeepSeek's training set. Now, onto what we actually did. We wanted to explore what was involved in bringing these models back into line with Llama while retaining the powerful chain of thought output that had been learned from the distillation of R1. For this, we generated approximately 7 million tokens of synthetic training data. We searched on various repositories for open data sets of questions, and we used a classification model to filter those into those that are about history and politics, those that are reasoning problems, and those that are safety related, for asking inappropriate questions and so on. We then generated answers to those to give us our synthetic data. We used Llama to output answers to the question on history and politics. We were prompted to give like as long as possible DeepSeek style chain of thought. And then we reformatted the outputs to match DeepSeek's chat prompt format. We used DeepSeek itself, the big R1, to answer the reasoning type questions. And then again, we used Llama to answer the safety type questions. And we wanted to include those to make sure that we weren't, as highlighted in the OpenAI paper, steering it unintentionally towards undesirable outputs. The reason for including the reasoning type questions is to avoid steering it away from the capabilities that R1's so well known for. We used PyTorch and the Hugging Face Transformers library to fine-tune the models with our synthetic data. We started with the 8 billion parameter model. This can be just about done on a single 80 gigabyte H100 GPU. On our first attempt, we'd clearly set the learning rate too high. The model's ability to generalize on reading problems was noticeably degraded, and when we fed it reasoning problems that weren't in our fine-tuning sets, it had lost the abilities compared to the original R1 distill models. And we needed to restart the process. Second attempt with a lower learning rate, running for around 12 hours on the H100. That was successful. We got the kind of outputs we would want from questions that weren't in our fine-tuning data for all types of questions, for the safety, for the reasoning, and for the things that may have been censored in the DeepSeek model. We then scaled up to the 70 billion parameter model, for which we needed to rent a machine with 8 96GB H100 GPUs. Again, we ran that for 12 hours. Our total costs include, in terms of GPU rental for this, were about £300 or €350. The results now. Here's the new 70 billion parameters model's response to the Belt and Road Initiative question from earlier. It's far less like a sales pitch, while still actually quite positive. See, now it does output a chain of thought, so it's not triggering the safety, the sort of short circuit safety training where it would just go immediately to a response where it refuses or outputs something that's been hard trained into it. You can see the chain of thought inside the think tags, and yeah, it should be noticed this wasn't in our fine-tuning training data, and the models obviously retain this information from its original Llama ancestor and the DeepSeek distillation. We did test both models with lots of other questions that the DeepSeek models are famous for refusing to answer. The responses are largely in line with Llama 3. And again, we tested a set of reasoning problems that weren't in our fine-tuning data, and the outputs are almost identical to the corresponding R1 distill models that DeepSeek released. Perplexity AI, the Silicon Valley company behind the well-known LLM search tool of the same name, released their own fine-tuned variants of R1. And they've quoted some controversy and headlines with their model that's called R1 1776 and some statements they've made about censorship. Their model says that it aims to remove all censorship. Perplexity shared some insight about the size of their training set and how they created it. They don't go into detail about how much compute they used. Their training set consisted of 40,000 prompts and answers, which is the same order of magnitude as ours. They also fine-tuned the 70 billion parameter distill model. It's safe to assume their compute requirements for that are on the same order of magnitude as ours as well. They did train the big mixture of experts model, which doesn't have Llama ancestry, and that probably required significantly more compute and would have required training on information that would have been missing from DeepSeek's data set. So I don't know how much they spent on that, but it would have been a lot more than we did. Perplexity have certainly done a great job of publicising this, but they've also caught some quite severe backlash too. You'll find plenty of heated videos about that on YouTube and corresponding comments, including it being asked all kinds of controversial questions. There are some more concerning examples, including quite a number of generative large language models that have been fine-tuned to negate the effects of not just censorship, but of all safety training. And then these have been published to public model repositories, which did start to take some of these down, but then started to face pressure from free speech activists. Some of these models will try to provide helpful responses to pretty much any instruction, from guidance on committing acts of violence to producing content filled with hate speech. There are models fine-tuned on conversations from places like 4chan, which is a unregulated and uncensored message board, and it will respond in the same sort of nasty manner that people respond on those boards. It's very hard to imagine that these kind of things aren't being used right now to fuel hateful responses on social media and other forums. The barrier for entry now to chat services for hosting chat services using fine-tuned LLMs with near to cutting-edge capabilities has dropped to the point where many startups and mid-sized established companies can start to offer their own versions of these based on how capable the open source models are now. End users have a choice, and based on what's gone before with both traditional media and social media, people are drawn to things that reflect their own worldview. And we already kind of see that to some extent. If you look how different Grok is to Claude and DeepSeek, and that people are using the thing that matches their preference. Thank you very much. You can find the models. We publish them to the Hugging Face repository at that URL. There's some instructions for running these on your own computer using an open source AI on our website, and we're in the process of putting free apps on the Windows and Mac stores to run it locally with a UI and an easy way of automatically downloading it and running it. Thank you. Does anyone have any question? Hey.
Well, thank you for the talk.
Cheers.
You mentioned like 40,000 prompts to kind of, realign the model.
Yes.
I'm curious about the size of the test cases that you use to actually validate that the alignment works.
Yeah, about 10%.
10%.
Yeah. So we just filter. We use 90 for the fine tuning and 10 for testing. Cheers.
Thank you. Follow-up question: how do you select that 10%? Right, these models are
Randomly.
Large.
Yeah.
Okay.
We tried to. The breakdown was probably about 60% history and politics questions, 20% reasoning, 20% safety, and then within each of those, random 10% we used for testing, and then just some subjective, we should ask it this kind of questions as well, just to.
So some sampling around the area that you're actually trying to
Yeah.
and then some randomization on
Yeah.
other topics.
Yeah, and also discussing with our client, because the motivation here really was clients have read about DeepSeek and they're just a little bit nervous about using it, and then just get the input from them. Okay, you try it, and let them ask it and see what they think. Cheers.
Thank you.
Anyone else? Hey.
You mentioned that after this kind of training, you like somewhat kind of see some degradation, how do you make sure the other parts of the model are not affected after your fine-tuning?
Yeah, you simply have to test it. Yeah, the only thing you can do is just by comparing the outputs of this to the outputs of the one before. And yeah, so the first run we did, we'd clearly, the learning rate was too high, and it had just gone completely in the direction of the questions we'd fed it, and not anything else. Yes. Anyone else? No? Okay, thank you very much. Cheers.